Happy Tuesday. Section 10.1, you already started grading. Number 14, which is the plug and chug to our calculators in radian mode. Toby, come on, grab your homework spiral so you can grade and then put it back. Number 24 was very similar, except you were doing tangent inverse. Now, you could have had the degrees or the radians, but the calculator didn't tell you this. What did you have to do to get this? Convert. No. Not necessarily. Your calculator would give you an answer, and it wouldn't match either of those. So that's not converting. Converting would be you're in radians to get to degrees, or you're in degrees to get to radians.
Either add 180 or pi.
Add 180 in degrees or add pi in radians, because the negative answer, remember, it fits the line, but it's not a natural way of explaining inclination. Number 28 was a simple rise over run. y2 minus y1 over x2 minus x1. But then when you solve for the slope, then you have to go ahead and find your inclination by taking tangent inverse. And I mean, this is a unit circle one, so maybe you guys went in the second quadrant anyway. You could have also done calculators if you have had negative 30 again. Sorry, negative 60 again, or negative pi over 3, you would have had to add it. 52, angle between. Did you guys use the formula? I would have. That was my advice yesterday, right? You would have had to rearrange, get your slopes, plug your slopes into the formula of m1 minus m2. I guess they did m2 minus m1. Either way, all over 1 plus m1 times m2. The nice thing with the absolute value is it doesn't matter which one's which, as long as you get them in there. But the 15/8 wasn't enough. You had to do tangent inverse to solve for theta, and then you would have gotten, that one would have been naturally right. You wouldn't have had to add anything because it was positive. John?
What was the first slope 3 over 2?
It's a typo. As you notice down below, it actually did end up putting the correct one of 3/5. So it's a typo. It should be 3 over 5. I'll go ahead and put this on top of it. There you go. It's a 5. Not a 2. You guys know if I try to write on top of it, it's not. So thank you, John. M1 was 3/5. M2 was negative 3/5. And the nice thing is, their work down here is correct. It was just a typo. Thanks for pointing that out. Oh, that's our last even. Let me get my cursor right back on top. What questions do we have? Janelle? Okay. I'm going to our PDF copy real quick and go into 10.1. But as I do that, any other questions, guys? Nope? All right. So peek at your homework spirals at 10.1, number 45, right, Janelle? Okay. This one was a graph. They gave us 2 different lines, and I think we're just finding the angle between. Good. And lucky for us, they showed us exactly which angle between they wanted. Which angle between they wanted. So with the angle between, hopefully you guys got y by itself. And as you got y by itself, what did the m end up being for the first one? Negative
3.
Good. And then, yeah, just the slope though. So negative 3. And then what's the slope for the second one? Okay. So if we want to plug into our formula of tangent theta, remind me of how the formula works. Good. Minus all over and then times, right? So I would have gone ahead and simplified, so 1 minus the negative 3 would be 4 all over negative 2, yeah? So that's absolute value, so set that equal to 2. And then tangent inverse. Ooh, but absolute value, right?
No.
So then the negative 2 became a positive 2. Tangent inverse of both sides. Did that match up with what you wanted? Okay. And guys, in homework, okay, good. It says in radians and degrees. I was going to say, hopefully they gave you some direction. I think all of them were saying radians and degrees, radians. All right. With that, 10.1, done. Got it, 10.2. Distance between. Angle between. We don't need distance between. I didn't assign that one, and then we're not going to memorize that one. So as you guys noticed from the homework, I'm going to go ahead and put this after the homework assignment. It was an optional homework help. I think the formula is probably the wisest way to go ahead and solve. At the end of yesterday, we were trying to compare to, there's my calculator, to the work that we had done by hand as far as finding both the inclinations and subtracting from 180 to solve for the angle that we saw. What I wanted to do really quickly today was to plug this in and see if our answers match. But I think you guys realized in homework, the formula is probably the easiest way to solve. I have negative 3/4 minus 2 all over, I forgot my absolute value was, so that's a bummer. And the inverse of absolute value. Some of you might have forgotten that in homework too, from what we were saying during class. There we go. Negative 3/4 minus 2 all over 1/4. Negative 3 over 2. In degrees. We're done. Oops, 79.695. Go team. We did it right, but the formula seems a lot easier, right? So I'm going to go ahead and just write that. Theta equals 79.695. That way you guys know that it matched up with what we had solved the long way on the page before. Okay, but with that we can finish 10.1. And I think you guys did well in homework, so I think we're good to go. Wow, that just skipped a lot of pages. Okay. 10. Ooh. This is a fun page. My non-artistic ones, I guess you can basically just write down basic conics and their names, and then degenerate conics and their names. I agree. My more artistic ones, just make it quick, don't go crazy. Maybe just do one double cone. You see the problem? It's how you slice it. You slice it straight across. You slice it at a slant, it's going to be an ellipse. It's going to be distorted. If you slice it up to the top or down to the bottom, you'll have a parabola. If you slice it straight down, you'll have a hyperbola. The degenerates don't take into account the curvature at all. And it's very special. If you slice right through the middle, you just get a point. If you slice along the edge, you get a line. And if you slice that one's straight down through the middle, you get 2 lines. Yeah. Just make sure you do the categories. Does that make sense? So non-artistic ones, if you don't want to make the double cone, you don't have to. It's a little chilly. It was super hot last class and everyone was falling asleep. Sorry. I'll get the air sheet off. But believe it or not, all 1, 2, 3, 4, 5, 6, 7 of these conic sections, all of them can be found in the standard form equation at the bottom. Some variation of it. Okay, x squared plus bx, y plus cy squared plus dx plus dy plus f equals 0. Every single one of their equations have some sort of components from down below. I know some of you are actually trying to do some of the picture, so let me just give you a second. But I want you to think about that formula down below. What would have to be true to make a line? What would have to be true to make a point? What would have to be true to make a circle? The A, B, C, D, E, F, some of them can be 0. Can you guys go look under your apps on your calculators and see if there's something on there about conics? Look under the apps button on your calculator and see if there's anything to do with conics. Yes, there's conics. Play around with that just a little bit and try to figure out what you can do with that cool app.
Oh, 2 intersecting lines. Circle. Oh no, I cleared everything on accident. Oh no.
Do you guys see this formula in there anywhere? Okay, let's see what you're able to find. What can that app do? You guys love the apps in your calculators, right? So when you went to apps and when you went to conics, I think I could just type C. You guys know you can jump to places in the menu by typing in the letter, right? Okay. What's this do? Uh-oh. Do you go to function mode? What's the info button do? That's boring. You see this one? That's a snazzy form of a circle that we've actually talked about before, standard form of a circle, but then what do you see down here?
Standard form right there.
Ooh, this thingamabob. But what's missing? Something's missing. F isn't there. Why isn't F there? I mean, there's a D, which means the same thing as F, right? Let me get rid of this screen. The D and the F are the same because neither of them have a variable with it, but what's actually missing?
The XY.
Yeah, the XY one's missing. The XY one's missing. So in coming in the circle, you could say, what is A? What? Why would A and A have to be the same? Why couldn't I have like a 2 there and a 3 there? Anybody know? Because of the radius. Yeah, for a circle, the dilations on the x squared and the y squared need to be the same. Interesting. Okay, so that's kind of cool. If we go back, how about an ellipse? Okay, wait a minute. Do you see standard form at all? So pause. Look at these equations for an ellipse. And if you notice, this one's more horizontally, this one's more vertically. How could we make this look like that? Yeah, we get common denominators. Multiply that up. That's good. We're on the right track. What else can we do?
Subtract 1.
Well, we're going to get common denominators and multiply. So we're going to have a squared times b squared. So we could subtract a squared times b squared, which would probably be the f. But what would we have to do to these guys? Foil them all out and get all numbers. So in order to get this to match that, we'd have to foil everything and get rid of denominators by multiplying. So how do you think we're going to get from here backwards? Grouping, complete the square, making it look nice and pretty and neat, and then getting one side equal to 1. All right, that's for an ellipse. What's going on for a hyperbola? Anybody go to that menu? That's number 3, right? They don't have standard form for this one either. But pause. How could you get to standard form? Okay, the common denominator, multiply, move everything to one side, and FOIL. How are we going to go from standard to this form? Complete the square. Get one side equal to 1, which will involve some division. All right. How about number 4? We've done parabolas. That's easy, right? Who's this 4P guy? What's going on in there? I thought we just called it A, right? A times x minus h or A times y minus k? Uh-uh. There's some new things a coming. Let's keep going. There's some new things a coming, but there's some review as well. So let's review. Vertex form of a parabola. We kind of just saw it. Vertex form of a parabola, which we started calling the standard form of a parabola. Back when we did that worksheet with maximums and minimums. Yeah, it was a long time ago, right?
Maximums and what?
Maximums and minimums. Two or three. I could have passed these back earlier. You guys probably would have lost them anyway. So we would have gotten thrown out with first semester stuff. So let's see what we did with vertex form. When you hear your name, come on down. Kevin, David.
Oh, oh, so I was only gonna
Let's go back in time a little bit. No. Kelly. Caro, Jacob, Joseph, Toby, Victor, Colby, do we have any idea when the ZTA coming up? Ryan, next. Caroline, John, Jack, and others. Andrew, Dean, Becca, Patricia, Thomas. Becca, you can look on to Patricia's because you didn't get one. I think that should be everybody. Uh-oh. Someone didn't turn it in. That would be good. So you would know from your grades last semester because you look real quickly just in case someone else got stuck in here. But guys, look at those questions that we were doing. Did we have to find the vertex in any of those? Yeah. And wasn't the vertex the max or the min? So in vertex form, what is vertex form? We called it a new standard, if you remember, right? It could be an any one. But then, yeah, x minus h quantity
plus k.
However, this is for what kind of parabola? An up-down one or a right-left one? Yeah. So this would be if a is greater than 0, it would be an upward-facing parabola with a vertex at hk. And if a is less than 0, downwards-facing parabola with hk. What's going to change if I need it to be a right-left facing parabola? Ooh, what just happened? Everything just got rearranged a bit. Because now, I still have the vertex hk. It's not going up or down, now it's going right or left. So now if a is greater than 0, now it's going to be going to the right. If a is less than 0, now it's going to be going to the left. Oh, did I just answer the orientations? Go team. I guess you can draw arrows up above. But I answered the orientations all in the same place. That's good. But what would, quick note, according to standard form of a conic, how would these look? According to standard form of a conic, how would these look? The equations, how would they look? Well, it wouldn't be all nice and factored like that. And didn't we have to complete the square a couple times on that worksheet? Or maybe we used, was there a hint to find the vertex? Was there a little baby formula we could use? Remember what that baby formula was? H equals negative. There's a little baby formula that we could find the H and we had cheat without completing the square and then plug in and find K. But remember, sometimes that was nasty because depending on how nasty K is, to plug them in and have to find what's going on. Because remember, what you were starting with was usually something like y equals ax squared plus bx plus c. Or if you look at your standard form, that would be the same thing as ax squared plus bx minus y plus c equals 0. That could be rearranged, get everything on one side. That's kind of more like a conic. Or it could have been x equals ay squared plus by plus c, which rearranged would give you ay squared plus minus x. This is just kind of tying in what we've already done with the whole standard form of a conic. Because if you see a conic or an equation in standard form with only one squared, you can automatically know that's going to go to a parabola. Because parabolas only have one variable to square. Whether it's the x squared or whether it's the y squared, both of these will point back to a parabola. If both of them were squared, now it could be an ellipse or a circle or a hyperbola, depending on the characteristics. As long as it's not degenerate. So, let's get specific with what they're going to expect us to be able to do and use and know. Alright, for a parabola. We're going into more detail than we have before. Nice thing is we've already practiced completing the squares, it's been a while. We've already done the vertex part, but this is going to ask for a few more things, like what's the focus? And where's the directrix? Well, here's a picture to remind us of what's going on. Parabolas can go many ways, not just up. It can go down or right or left. The focus will always be inside the curve, inside the parabola's branch. I always think of it as they're always going to be eating the focus, and the directrix is always going to be on the outside. You can also think the directrix never intersects. So it couldn't be here. If it was here, it would intersect. If it was here, it would intersect. It needs to be outside, perpendicular to the axis of symmetry. Bless you. You're going to see some problems that deal with lenses or mirrors. You can think flashlights, because there are things called parabolic reflectors. We'll get into that when we get to an example like it. And that focus is actually kind of important in things like flashlights. How are flashlights and lamps different, as you guys are writing? How are flashlights and lamps different?
Flashlights are directed.
Flashlights are directed. The beam is directed, whereas lamps are more like, just fill all the beams. Flashlights are directed, whereas lamps are like, just fill everything. So what's the difference in the construction or in the way of displaying the light or having the light displayed that makes the flashlight be directed and the lamp to not be? Do any of your families have the really old flashlights? Like the big old huge batteries in the handle, and then you can like unscrew the top and see like the light bulb in there? What's true about that little place where the light bulb is? Parabolic, and it's a reflector. If you ever look at it, it's like a little mirror in there. parabolic reflector. And guess where the light bulb, guess where the light source is? At the focus. Interesting. Yeah, if you know what one of those old flashlights looks like, is a magnum light the same thing? I haven't looked in depth at a magnum light. Because some of those old flashlights are like the big old handle, not like the little keychain ones where you just kind of like click the button. A parabolic reflector is used so that the beam can be directed in a certain location and not just be diffused like a lamp. Anyway, all that to say, a focus is specially defined in the directrix as well in that at any point on the parabola, the distance to the focus and the distance to the directrix is the same. They're not all the same between each other, but at any point, the distance to the focus and to the directrix from that one point must be the same. So as you guys notice, these are labeled the exact same D2 and D2, D1 and D1, because they need to be congruent, they need to be the same. But the cool thing is that we can actually find where they're supposed to be all based on that equation, and it all comes back to A. It all comes back to A. In the olden days, aka when we were doing that worksheet, or even just on the page before, we would say A times, usually we put it over here, A times x minus h squared, or A times y minus k squared. But in order to be able to figure out where the focus is and where the directrix is, we actually need to rearrange things just a little bit. And so hopefully you guys wrote down that we're going to actually move the A to be with the non-squared component. So if it's here, we'll divide it over there. We're going to move the A to be with the non-squared component. And we're going to set, in a sense, we're going to set the A equal to 4p. But we're going to have to go ahead and, real quick note, that 4p is just going to be a number. So we're going to have to go ahead and set whatever number, whatever coefficient we have equal to 4p and solve for p. We're going to have to actually set whatever coefficient we have equal to 4p and then solve for p. There are two different ways that parabolas can be oriented, so let's go ahead and see why these little formulas are what they are. This entire chapter, some of you are just going to need to get down the logic of how everything works, and then you'll be able to repeat it, but some of you might need to do a lot of memorizing. If we have a vertical axis of symmetry, so if my parabola is oriented this way, if my parabola is oriented this way, my directrix needs to be a y equals line. And my y equals line is going to need to be, go to k, go to the y value of k. And then I need to go ahead and subtract p, because I need the directrix to be below k. So the reason why my directrix formula is y equals k minus p is for this type of parabola, my directrix is going to be the opposite direction of k. Now, I could show you a different example. I'm not going to leave it up here because it's going to get a little confusing, but what if it was shifting down? Where does my directrix need to be if it needs to be outside the curvature? Is my directrix below or above? Above. So then, wait, how is k minus p going to help me on this one? It's the exact same formula, but in this one, isn't my coefficient going to be negative? And if it's negative, well, if I do k minus a negative, what am I really doing? Adding. So the nice thing is this formula right here, y equals k minus p, will always work whenever I have an up or down parabola to get me to the right place for the directrix. But do your eyes see where the directrix needs to go? Outside the parabola or outside the parabola? So here's a question. What if my parabola was facing this way instead? What if it was facing to the right? Where does my directrix need to be? Above, below, to the right, or to the left? Yeah, it's going to be to the left. Why? It needs to be outside. So if it's to the left, well, I'm not going to be doing a y equals line anymore. Now I'm going to be doing an x equals line. So my vertex is going to be at h, and I'm going to need to back up that p distance to get to my directrix over here. So I'm going to do h minus p, which is why you see this as the formula. I'm going to take the h and subtract the p. And if you think about it, if it was facing the other direction, my coefficient is now a negative p. And so h minus p would actually add it, and it would be to the right. So visually, my directrix always needs to be outside the curvature. And if I have an up-down, it's going to be a y equals line. And if I have a right-left, it's going to be an x equals line. Okay. All that to say, what about the focus? Directrix is a line, y equals a number, x equals a number. Focus is a point. Directrix is a line, focus is a point. And the nice thing is, if you have a vertical axis, or if you have a horizontal axis, we can actually use the clues up above to help us get what we need. Because the focus is p away also. It's the exact same distance. If I was to come up here and show you. This distance to the focus and this distance to the directrix, both of them are going to be the distance p, the absolute value of distance p. The distance from the vertex to the focus and to the directrix is the exact same thing. That's why that p coefficient is so important. So for the vertical axis, the point, instead of subtracting p from k to get to the y equals line, I'm going to add p to k to go the other direction, and I'm going to keep the same x value. I'm not changing the x, I'm just going up. So I'm going to do k plus p, and my h has remained the same. That's not changing. Or over here, instead of h subtracting p, now h is going to be adding p. And my k is going to stay the same. It's too cold, turned off the air, now it's too warm, you guys are all warm. Such a struggle with it. Now guys, I know this page has been really boring, a little intimidating. But let me just ask you a couple things. How far away from the vertex of a parabola is the focus and the directrix? How far away? Good. How do I find p? I rearrange and then set the number equal to 4p and solve. Does that make sense? We'll try it, don't worry. And then how do I know where I'm going as far as in or out? Who's inside the parabola? The focus or the directrix? Is inside the curvature, and who's outside? Focus is a point. Like if you focus on one point, focus is a point. Directrix is a whole line. Okay, so with that, let's see what we can do. Let's see what we can do. We're just playing with the information that we know. Find the standard form of the equation of the parabola with the vertex at the origin and the focus at 2, 0. Find the standard form of the equation of the parabola with the vertex at the origin and the focus at 2, 0. My advice for anyone who is at all visual in any way, shape, or form, my advice is to graph it. If you're visual in any way, shape, or form, either visualize the graph, if you can do that, or draw the graph. You're like, I don't have a lot. I know, but you do have some. Visualize. Where's the origin?
0, 0.
Easy. So 0, 0 is my HK. Where's my focus?
2, 0.
What kind of parabola do I have if I need the curvature eating the focus? I need a sideways parabola, right? Now, you could do a dotted line, like, I'm not exactly sure. I know it's a sideways one. Well, if it's a sideways one, can't I match that to the equation? Can't I match that to, well, that's going to be an x minus h squared one. No, that's a normal one. That's an up-down one, right? What's the right-left one? Y minus k squared. This is a little weird. It's not our normal standard form from, or vertex form from way back first semester, but that makes sense. We're second semester. We're progressing a bit. So if you guys want, check it out. Didn't I put the up-down one next to the x minus h squared to help you guys out? Vertical axis of symmetry, an up-down parabola is this guy. Horizontal axis of symmetry, a right-left parabola is this guy. So we just stole that equation, right? Hold on, what do we know? What can we plug in? Is it what? P is 2. I was thinking my vertex might be the easiest thing to plug in, but yeah. You can plug in your vertex at 0, 0. And then Andrew said that P was 2, and how do you figure that out? The distance was 2 to the focus. What would the distance be back to the directrix? Also 2. If I needed to, it should be 2 in the opposite direction. So the distance is 2, so I can go ahead and plug in. Oh, P is 2. Which means 4 times 2 is 8. Now technically, is that right? And the answer would be yes. Is that in standard form? No. The nice thing is they don't necessarily mean standard form of a conic, at which point we've moved it all to one side. They just mean standard form as in an equation. You could stop there. If you wanted to make it like a conic, you could go ahead and do y squared minus 8x is 0. That would be what the conic would do, would move it all to one side. But both ways work. So we figured out it was a sideways parabola because the vertex was at 0, 0, the focus was horizontally away, so I knew it had to be a right facing. And guys, just double check real fast. Right facing, is that a positive parabola or a negative parabola? Good, double check. Did you make it the right sign? Yes. So then you guys' turn. Still the origin, so I'll put that in parentheses because I didn't write out all the directions. Still the origin is the vertex, but something has changed. Now the directrix is y equals 0. Take a second. Take 60 of them. Take a minute. Let's see what you guys can get done. So no longer focus at 2, 0. That's not there anymore. The origin is still at the vertex, but now there's a directrix at y equals 1. Anybody who is watching the video, I am freezing the screen and writing the answer, but they can't see it yet. Do you guys draw a picture? You didn't draw a picture, do that first. Y equals 1, what does that mean? Is that a point or is that a line if it says directrix? It's a line. So do you have a horizontal line at y equals 1? There should be a horizontal dotted line at y equals 1. Then ask yourself, what makes sense? Is my parabola going up from the origin, down from the origin, right from the origin, or left from the origin? There's only one that makes sense. Yeah. If you guys have gotten an answer or you're close to getting an answer, you can check out my answer and see if you agree. But for those of you guys that are like, okay, graph. Origin, y equals 1, make it a line. The only way that parabola, it couldn't go up, it would hit. It couldn't go right, it would hit. It couldn't go left, it would hit. It needs to go down. Then the directrix is outside the curvature. So my parabola was doing something like this. You guys probably see why I have just x and just y, because who's my h and who's my k? Yeah. So my h and k were just 0, 0, no big dealio. But how on earth did I figure out it was -4?
The P is -1 because the rectrix is 1. It's in the focus.
My distance is 1 except, hold on, wait a minute. My distance is 1 except I needed my P to be negative. You can think that P is always the distance to the directrix specifically, and so and this one, sorry, so the focus specifically. And this one, the distance was a positive 2 to get to the focus, and this one, to get to the focus, it would have had to go -1. So even though the distance is 1, the negative sign comes from basically the curvature needing to be down, or think the distance to the focus would be a negative. So if it's easier, you can say, oh, it's 1. Oh, focus is down. It's -1. Dun, 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 dun. And if you wanted to, you could move it all to one side to make it look all nice and pretty like a standard conic. Do the pictures help? I think so. Because it gives you a starting place. Without a picture, you're like, I'm not even sure what kind I'm doing. Is it right? Is it left? Is it up? Is it down? And then the right, left versus up, down helps you make sure that your sign is good. This one had to be positive. It was going right. This one had to be negative. It was going down. Just a quick little double check. Now, pause. Don't write. Pause. Some people might do better on the test if they memorize this whole page. But didn't we just figure out 2 problems given information without having all this memorized? They gave us a focus and a vertex. We're like, oh, of course it's going to be. Okay, plug in. Could you memorize every single little piece of information? Yes. Could you memorize every single little piece and be able to write it down and still do horrible on the test because you don't understand how to use it?
Yeah, cool. Yeah.
Maybe you don't have to memorize every single thing on the page. It's on the notes. They'll be saved online. It's totally fine for you guys to check out, write down, flashcard, memorize, but I don't know if you need it. So let's see, just using what we know, just using that little yellow card, basically that little yellow piece of information where I summarized everything. Let's see if we can figure out, even if the problem gets trickier. So let's do this one together. What am I going to graph? Okay. 0.22. Got it. That's my focus, right? What else did they tell me? What kind of line is that? Horizontal or vertical? Remember, x-axis, go to -2, and then follow the line. X-axis, -2, follow the line. Where's my parabola? How is it oriented? Right, left, up, or down? Has to be, oh, not up or down. I'm going to be in huge trouble if it's up or down. It's going to have to be, you guys done? It's going to have to be right. Now, here's the question though, where's the vertex?
0 to 2.
Halfway in between. Right? Halfway in between. So the vertex is going to, that was just in the picture, halfway in between the focus and the directrix, so I can say the vertex is 0, 2. Alright, cool kids. I'm doing a right-facing parabola, which means we're going to be using that equation, right? Which is y minus k squared equals 4px minus h. We can plug in the 0 for h. We can plug in the 2 for k. Who else do I need? And who is p? Positive or negative?
Positive.
Because I'm going to the... So, I have 1 minus 2 squared equals 8x. Now, that's great, that's good. What if they wanted the conic section formula? Ugh. We're going to have to do some nastiness, right? And have y squared minus 8x minus 4y plus 4. Do you see how it gets hidden if we go going into that standard form? Check in homework when you're doing the homework exercises. I believe when they say standard form, they mean of a parabola. So this would be good, which is why I've been boxing it. But every now and then they might either give this to you and you have to group, and complete the square, and then try, this could get to be a hard thing. But if they give you this one, you're going to have to group and use complete the square to get here. But otherwise, if you're using tricks and clues, you're making it so you can leave it in the form that you got it. Let's peek real quick at what we have left for this section. Okay, are we done?
No.
So, are you starting homework? Yes. Are you finishing it? No, because homework is not due until Thursday. Bye guys. See you later.
Wait, Miss D, do you want the handout back?
No, you can keep it. It might be helpful for completing the square review, right? My TA wasn't here this period, so check out your school. My TA next period is gonna look for it. You're welcome.
Can I use this spoon? Or do you have only 4 times?
Depending. I might have some like restaurant silverware. I might have a spoon in it.